Hello and welcome back to Faraday Academy. This is a continuation of the serverless development series. In the last video, I left off with deploying a basic Lambda function with AWS Claudia. And in this video, we're going to deploy a more complicated application with an API and also connected to other AWS services. If you're new here, my name is Gwen and I make various programming tutorials and other videos on programming related topics. So if you are interested in this type of content, then please subscribe to see more. In the first video of this series, we went over the basics of AWS serverless deployment, installed the AWS SDK locally, created a user, configured permissions, installed Claudia.js globally, and deployed a Lambda function live to our AWS accounts. In this video, we are going to build off of that by adding a deployment of AWS's API service to connect to and provide an API for the Lambda that we are going to deploy, which will in turn connect to other AWS resources. In this case, we will be using a policy to connect our AWS Lambda to be able to perform CRUD operations on a Dynamodb table. Claudia will handle the deployment of our API endpoints through the API Gateway service, as well as the functions with all of the logic for our application to AWS Lambda. Any other services we use, like Dynamodb, will be deployed separately through the AWS SDK or the console. Here is what our application will look like. In the past, I made a Vue.js tutorial for a pet adoptions web application. This will be the serverless backend for that application. I will link both GitHub repos below. Requests will come in from the client to an API gateway endpoint, be sent to Lambda functions, where we will have logic to perform CRUD operations on our Dynamodb table. Now I have laid out a schema for the table here, but remember that Dynamodb is schemaless. So any logic we have for type checking and object mapping will have to be done in our Lambda function. In the AWS Management Console, go to Dynamodb and select Create Table. Here I'm going to give it the name Pets Demo, and then set up a primary key, which will uniquely identify every item in our table. Now this is not the same as some other NoSQL type databases like Mongo that automatically assign an ID to every item. Here we will have to generate the ID in our Lambda functions before we post items to a Dynamo table. To keep it simple, I'm going to keep the default settings and click Create. AWS might take a few minutes to set up the table. Once it's ready, you can go to Items and create your own items, either in the tree view here or using standard JSON. I'm going to go ahead and add one item so we can test out our services by using a basic GET request. And click Save. And now I have the first item in the database. Now let's deploy an API and Lambda function to connect to this table. Here in my terminal, I'm going to start off by initializing an npm project and just using the default values, which is fine. I'll clear that. And I'm also going to create a JavaScript file, just like in the last video, to house the code for my Lambda and also my API endpoints. Now in my folder, I have the package.json as well as the index.js file. Since I am deploying an API as well this time, I will need to install one additional Claudia package as well as the AWS SDK. Now in my project, I'm going to go to the package.json and change the name to Pets Demo. Now Claudia will use this name by default when it deploys resources and creates the IAM role, but I can optionally pass in a value for name via the CLI. In this case, I'm just going to use the default in the package.json. You can see I have my two dependencies installed. Now I'm going to start creating the API. In the index.json file, I'm going to paste in the required packages, and then I need to create a new API. Once I've done that, I can use methods that are found on the API object. So I'm going to use the get method. The first argument is the endpoint. So in this case, I'm going to say pets, and then I pass it a function. And now I can return whatever value I would like. For testing purposes, I'm just going to return a string. And now I'm going to attempt to deploy this with Claudia. In my terminal, I'm going to use Claudia create again. Pass it my profile, the same profile that I used in the last video, which refers to an IAM user that has access to IAM, API Gateway, and AWS Lambda services. When we were deploying the Lambda function last time, we denoted a handler. In this case, instead of a handler function, we are going to set the API module, which in this case is the file we created called index.js. Now we can set the region, which in my case is US East 1, and hit enter. Claudia is giving me an error saying that I did not properly export the API builder instance. So back in the code, I need to do a module.exports equals API. Now I can attempt to redeploy. I'll just press the up arrow key to get the same command I used as last time. Hit enter. Claudia is zipping and uploading my package, as well as creating the REST API endpoints and a new IAM role for the Lambda function. Now that my resources have been successfully deployed, I can grab this URL, paste it in my browser, hit enter, and I receive a message saying missing authentication token. I am getting this error because I need to attach a valid endpoint to the URL that API Gateway has created. Back in my browser, I'm going to add /pets, hit enter, and now I receive a success message. I can also see that my pets demo API was successfully created in Amazon API Gateway, as well as the matching Lambda function and its execution role. Notice that after you successfully run Claudia creates its own JSON configuration file with the API and Lambda configuration options. This file is important for being able to update and manage your serverless infrastructure through Claudia. Before I continue, I'm going to remove the Claudia test deployment that we just made using Claudia destroy and passing it my profile. This will remove all of the deployed resources, including the Lambda API and associated role that was created by Claudia. You will also notice that it deleted this Claudia.json file, and it is no longer in the directory, meaning we can update the code and now do a fresh Claudia create to deploy. I'm going to create a new instance of the Dynamodb Client from the AWS SDK. Now I want to point out here that using the document client is not the same as referencing the Dynamodb client directly, but this abstraction does make it much easier to work with and perform most standard operations such as CRUD operations on a Dynamodb table. If you look on Stack Overflow and other websites, you might see different examples, but I highly recommend that you start with the document client until you have a specific use case to use something else. Now here, instead of returning a string, I want to use a scan operation and return every item that I have within that Dynamo table. I'm going to return my Dynamodb instance .scan. This is the simplest operation because I just need to pass it my table name, which is pets demo. I'm going to create a promise and then chain a dot then. From that, I will get the response object, which I can return response.items, which will be all of the items in an array from the Dynamodb database. Claudia lets you return a regular value or a promise. If a promise is returned, it will wait until the promise is resolved, and then because a .then is chained here, this will be the response that's returned from the API to the client. There's one more thing we have to do before we can deploy this, which is give our Lambda access to this Dynamodb table. To do that, we need a policy. Fortunately, Claudia can manage this for us. We'll create a policy folder here and add a Dynamodb policy. I'm going to paste this in because it's pretty standard. AWS requires that you have a version. And then here we're denoting what actions are going to be allowed to be performed on this AWS resource. We could denote multiple resources or use an asterisk for all resources. Since we're only using one table in this demo, I'm going to leave it as it is. Now we can deploy once again with Claudia create, pass it the profile, our API module, which is index, region, US East 1, and this time we're going to tell it that we have policies we would like to add with the policies option. We are pointing this to the policy folder we created, which in our case only has a policy for accessing DynamoDB, but we could add more policies in that folder if we wanted to. I'm going to hit enter here. It's zipping our Lambda file and again creating our API and Lambda resources as well as a role for the Lambda. And this time it attached a policy to that Lambda for us. Now I'm going to grab this new URL and test it out in the browser. And it returns our items in an array from DynamoDB. This is more clear if I go to REST client, which is a similar app to Postman, except for Firefox. I will paste it in here. I'm making a GET request, and I'll hit send. And it comes back with a status code of 200, and I can preview the array of objects. Now let's configure our post request on our resource and then set up item endpoints. To configure the post request, I'm going to use the post method on API and again pass it the endpoint and then a function. This time I'm going to want the request object. One nice thing about Claudia.js is that it handles a lot of the configuration of API Gateway under the hood for you, so you don't have to set up things like body parsing manually, and we get access to request.body on the response object by default. So in this function, I'm going to do two things. First, I'm going to set the params that I'm going to pass in to Dynamo to create a new object, and then I'm going to put the item in the Dynamo table. So this params will be an object, which must have a table name. That is pets demo, and then I have to define the item, which I am just going to paste here. You can see I'm getting all of these attributes from request.body that's being passed into the function. I'm also using the built-in JavaScript methods date.now to create a timestamp for the created and updated at properties. To ensure that the ID is unique, I'm going to bring in a third-party library called UUID from npm. npm install UUID. Now I can import it in my project. Save. And this is all the configuration I need for the parameters to pass this item into DynamoDB. So now I will return another promise here. Return. Pass it my params. And then return it as a promise. In this case, I don't want the default status code for this request. I would like a 201, so I'm going to denote that here. Save this, and it's ready to deploy again. Instead of redeploying here, I'm going to use Claudia update to rebundle and add my changes and pass in my profile. Claudia is re-zipping it with my additional npm package that I installed for UUID. Now I'm going to test out a post request in my browser. First, let me make sure that get is still working. Still coming back with the correct response. So I'm going to try post, paste in a body. Remember that ID is automatically generated already, as well as the created at and updated at fields. I'm going to take one more step here and add a header, which will be content type of application JSON. You can see it's an empty object, but if I go to headers, I get the correct status code for created returned to me. And now I can try to get all of the items from the Dynamo table. And you can see I have both items, the original test item plus the one that I just saved with my post request. Now let's add the item endpoints. So it will basically be the exact same API, except we will be able to perform CRUD operations on items by copying an ID and then using get, put, or delete requests on this endpoint. I'll start here with the get request, and I'll use the same pets endpoint, and this time I'm going to have ID in the params here as a variable. And with my function, I will once again need the request object. Now to get the ID out of my params, I can use the JavaScript function decode URI, and I will pass it request.path params.id, and I'm also going to create a params object just like I did in the post request, but this time I'm not creating or updating an item, so I don't need to pass it an item. I do still need the table name, which is pets demo, and then I need to pass it a key because I only want to get back one item from the database. So I'm going to tell it which key I want by passing in the ID. And now I will return another promise from Dynamo. Pass in my params, get a promise, and then chain a .then on. Again, I want my response, and I'm going to return my response .item, which will just be the object that belongs to this ID in the pets demo table. So let me save that. And I'm going to come and create my put and delete requests as well. So api.put, the same endpoint as last time with ID. I'm going to copy these two things from last time, the params and how I'm pulling the ID. But in this case, I don't just want to refer to the item, I want to update it. So I'm going to change this to item. I still want to refer to it by its ID. I'm going to take a little bit of a shortcut here, and only because I'm the only one going to make calls to this API. Going to go ahead and pass in whatever key value pairs are passed through request.body. Now I'm going to copy this return statement, but instead of get, of course, I want put here, and then I don't really need to return an item. It's just going to return whatever status code. So I'm going to get rid of this, and for right now I'll just return the ID. I'll also remove this response object, and now I will do the same thing for delete. I'm going to actually copy this get and paste it down here. Change this to delete, and here as well. Get rid of the response and return ID here. And one thing I want to change from the default is that I want to return this ID in plain text. So I'll set that here as the content type will be text plain, and I'll copy this and also paste it here for delete. And this should work for all of the CRUD operations on our API. Let's update Claudia and test it out. The update was successful, and now we can indeed test this GET request, which worked and returned the object of the item just as we expected. Now let's try updating this item, and let's say our cat had a birthday. He's going to age by 1 year, and I will send that as a put request. And we got our ID back as plain text, just as we expected, with a 200 success response. So now let's try to delete this item. Change this to delete, send that, and it worked. So I got the ID back of the deleted item. And now if I do a GET request on all pets, I only get back the one that wasn't deleted. So now I have a fully functioning API with get and post requests on the resource and get, put, and delete requests on the item endpoints. The final thing to do is to clean up after this tutorial. So I'm going to say Claudia destroy once again with my profile. And that's it for part 2 of this tutorial. In part 3, I'm going to show more Claudia configuration options and serverless API use cases. If you like this content, please don't forget to like, comment, and subscribe. It really does help my channel. And if you'd like to support my work, then please share this video with people that you know. And I also have a Patreon account, a PayPal link, and a published book for purchase that you can find in the description below. Thank you so much for watching, and I will see you in the next video. Have a great day.